Hello and welcome to this short video lecture on the solutions to the prerequisite readiness assessment questions that was given out last week. Of course, these are the instructions, and I believe you already have gone through them. I'll dive directly into answering or solving the questions. The first question is on matrix inversion, and it reads: consider the matrix A with the elements 2, 1, 0, 1, 3, 1, 0, 1, 2. Question A: compute the inverse of A using the Gauss-Jordan elimination method. Show all row operations clearly. Question B: verify your answer by computing A inverse and confirming it equals to the identity matrix I3. Question C: state the determinant of A and explain its significance for the existence of A inverse. I'll solve the question right away, and I'd like you to follow along very closely as we solve this together. If you have any questions, please do not hesitate to ask those questions either through the comment section, or you can bring them up during the lecture when next we meet. Solution. Okay, the first let's start with part A. The first step to take is to recall what it means to solve for the inverse of a matrix using the Gauss-Jordan elimination. Let us set up the form which is referred to as the augmented matrix for the Gauss-Jordan elimination method. Using Gauss-Jordan, using the Gauss-Jordan elimination method, we have to set up the augmented matrix or matrix, which is set up the augmented matrix. Set up the augmented matrix, which is given by A I, that is the matrix A, which is the given matrix, and the vertical line I. Excuse me. This is going to be I3 because it's a 3 by 3 matrix we're dealing with. So let's set the matrix up. Don't forget the matrix has the elements 2, 1, 0, 1, 3, 1, 0, 1, 2. The augmented matrix be presented as follows: A given I, or A vertical line I, is equal to 2, 1, 0, 1, 3, 1, 0, 1, 2, with my vertical line 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is the augmented matrix. That's the first thing you have to do when solving for the inverse of a matrix using the Gauss-Jordan elimination method. The next thing to do, let me call this step 1, or okay, step 1. We want to eliminate or reduce. We want to reduce this matrix to what's it called? Canonical form. Right, so we want to reduce the matrix to canonical form, and we're looking at the left matrix, the matrix A, the actual matrix A that was given. So the first goal is to make the pivot element 1. The first pivot element. What is the first pivot element in the matrix? The first pivot element is the first element on the first row. This is the first pivot element. So our goal here is to make that first pivot element become 1. All right, let's see how to achieve that goal. And what do we do to make that pivot element become 1? We are going to perform a row operation by multiplying the entire row 1 by half. Okay, so step 1, I'm going to multiply row 1 by 1 over 2 to make the first pivot element 1. Let's do that right away. When we multiply 2 by 1 over 2, that will give 1, because of course. And then the next element to be 1 over 2. The next element is 0. The next element is 1 over 2, 0, 0. So this is the first operation. Other rows will remain the same. All right, 0, 1, 0, 0, 1, 2, 0, 0, 1. With this, the first element has become 1. The next step to take, step 2, we need to perform another operation. This time around, we want to make all the elements below the first pivot become 0. Already, this is 0, right? Here is it 0. So we need to make this element become 0. And what do we do to make that element be 0? The row operation to perform to achieve that is to replace the second row, R2, by the difference of the second row and the first row. So I'm going to subtract the first row R1 from R2 and replace the results R2, that's row R2. So row 1 will remain the same, 1, 1 over 2, 0, 1 over 2, 0, 0. Then row 2 becomes, don't forget we're doing R2 minus R1, so 1 minus 1 is 0, 3 minus half, that is 5 over 2. When you subtract half from 3, you get 5 over 2. Then 1 minus 0 is 1. You're taking nothing out. 0 minus half is minus half. 1 minus 0 is 1. 0 minus 0 is 0. So the third row will remain the same. 0, 1, 2, 0, 0, 0. So here is the vertical line. And we have the matrix. We've achieved our goal of making all the elements under the pivot become 0. So this is 0 and this is 0. Fantastic. Our next goal is to make the next pivot element 1. What is the next pivot element? This is it here. I want to make that next pivot element become 1. So what row operation do we perform to achieve that goal of making the next pivot element 1? We need to multiply through row 2 by the inverse of 5 over 2, and the inverse of 5 over 2 is 2 over 5. That is, I will replace row 2 by 2 over 5 row 2. Okay, replace row 2 by 2 over 5 row 2. Let's perform that operation. I need to fold my laptop so that I don't get it. Okay, good. This is perfect now. Let's perform the row operation. Performing the row operation, this should become okay. So this should become, so the first row will remain the same. 1, 1 over 2, 0, 1 over 2, 0, 0. The second row we have 0 here. When you multiply 2 over 5 by 0, that is 0. 5 over 2 by 2 over 5 is 1. Then 1 times 2 over 5 is 2 over 5. Minus half times 2 over 5. Let's multiply minus 1 over 2 times 2 over 5. That will give us minus 1 over 5. Minus 1 over 5. Then 1 times 2 over 5 is 2 over 5. 0 times 2 over 5 is 0. Okay. Then the third row remains the same. 0, 1, 2, 0, 0, 0. All right. And this is what we've obtained. Beautiful. The next step is to make the next pivot element, which is, all the elements above and below the pivot element become 0. That is the next step. We want to make all elements above and below the second pivot element be 0. That is, this has to turn to 0, this has to turn to 0. All right, and how do we achieve that? How do we make all the elements below and above the next pivot element become 0? So what we need to do to achieve that, that's the fourth step. Step 4, looking at it closely, first we will have to subtract from row 1, we'll subtract 1 over 2 row 2. Let's write it down. Row 1 will be replaced by the row operation R1 minus 1 over 2 R2. That's what we'll do to achieve 0. And the second operation we will need to perform for row 3, the row 3 will be replaced with just row 3 minus row 2. Okay, did you see that? Let's perform those two operations, the two row operations. The first, row 1, 1 over 2 times row 2. Okay, 1 over 2 times 0 is 0, so 1 minus 0. Okay, I think, yeah, row 1 will be replaced. 1 minus 0 is 0, is 1. Then 1 times 1 over 2 is minus 1 over 2. 1 over 2 minus 1 over 2 is 0. We've achieved that. Now let's multiply minus 1 over 2 times 2 over 5. Our answer becomes minus 1 over 5. So minus 1 over 5, 0 minus 1 over 5, we give minus 1 over 5. We give plus 1 over 5 rather. Okay. 0 minus, okay, that is minus 1 over 5. Because we are adding them. Are we adding or subtracting? It says R1 minus 1 over 2 R2. Okay, we are subtracting, so that's going to be minus 1 over 5. All right. Then minus 1 over 5 times minus 1 over 2. So minus 1 over 5 times minus 1 over 2. That's equal to plus 1 over 10, right? And then we're going to subtract 1 over 10 from 1 over 2. So 1 over 2 minus 1 over 10. The LCM here is 10. That's 5 minus 1. So that's going to be 4 over 10. Is that correct? 4 over 10, and that will give 2 over 5. That's correct, right? I hope I'm performing the operations correctly. So we multiplied 1 over 2. Okay, let me take this off. So we multiplied, where did I start from? 1 over 2 multiplied by, let's do minus 1 over 5 multiplied by 1 over 2. So the answer here is minus 1 over 10. Okay, that's the answer, minus 1 over 10. So which means that we are actually going to perform addition, because we have 1 over 2, right? That's what we want to do, minus 1 over 10. That is 1 over 2 plus 1 over 10. So this is 10. 5 plus 1, that's 6 over 10. And when you divide this, that's to give 3 over 5. That was my mistake earlier. 3 over 5 is what's supposed to be there. 3 over 5. 3 over 5. Then, let me write this clearly. 3 over 5. Then, we move on to the next element, 2 over 5. So I'm going to multiply 2 over 5 by 1 over 2. Let's clear this rough space off. So let's multiply 2 over 5 by 1 over 2, okay? 1 over 2 times 2 over 5. That will give 1 over 5, right? Then when we subtract 0 from 1 over 5 from 0, the answer will remain minus 1 over 5. And the last element is 0, because when you multiply a number by 0, you get 0. The second row remains the same. We're not replacing that. 0, 1, 2 over 5, minus 1 over 5, 2 over 5, and 0. The third row, we are performing the operation R3 minus R2. So 0 minus 0 is 0, 1 minus 1 is 0, 2 minus 2 over 5. All right. So this is 5, that is 10 minus 2, which is 8 over 5. All right. Um, I hope that's correct. What am I subtracting from what? R3 minus R2. 10, 5, 8 over 5. R3 minus R2. I hope I'm doing this correctly. My R3 here is 2. Minus, yeah, that's correct, 8 over 5. So we have 8 over 5. Then 0 minus 1 over 5, that is plus 1 over 5. 0 minus 2 over 5, that is minus 2 over 5. 0 minus 0 will give 0. So that is the matrix we get when we apply the first step. Okay, and the next operation we will be performing is to ensure that the third pivot element become 1. This guy here. Take a step to ensure that the third pivot element become 1. That will be fifth step, step 5. And what elementary row operation can we perform to achieve that objective? We have to multiply the entire row, row 3. So row 3 replaced by the inverse of 8 over 5, which is 5 over 8, row 3. Okay, let's perform that operation. When we perform the operation, row 1 remains the same, 1, 0 minus 1 over 5, 3 over 5, minus 1 over 5, 0. You have 0, 1, row 2 remains the same, 2 over 5, minus 1 over 5, 2 over 5, 0. And then we have multiplying 0 by the inverse, it will keep these numbers as 0, and this becomes 1. So I'm going to multiply 5 over 8 by 1 over 5. So that will give 1 over 8. I'll multiply 5 over 8 by minus 2 over 5. That will give minus 1 over 4. And when you multiply 5 over 8 by 0, you get 0. So this is the matrix. The result we arrived at with my vertical line when we apply step 5. All right. This is becoming beautiful, right? I hope I've not missed out something somewhere. So I see there's been a mistake somewhere. Uh, let me see. Okay, so I missed out something somewhere. Sorry about this. From step 2, R2 minus R1. This is 1. 1 minus 0 is 1. So this is meant to be 1, 1, 1. Sorry. That's a mistake. Let's quickly correct that mistake. 1, 1, 1. So this is supposed to be 1 because when you subtract R2, where is it? R2 from R1. How come did I make such mistake right from the beginning? Step 1. This is 1 from step 1. Yes, this meant to be 1. Then step 2. That's not supposed to be affected 1. Then step 3. This is still 1. Step 4. After step 4, it still remains 1. Now step 5. This is going to be 1 times 5 over 8. That's meant to be 5 over 8. Please, sorry, I didn't see that earlier. Okay, so I hope it's now very clear. Let's get through this. Let's get through this. So sometimes when you're performing calculation, you have to be very careful with the figures so you don't make mistakes. Okay, we would continue right here. Now, the last step we'll be taking is to ensure that these two elements above the third pivot elements are 0. That's the last step. We want to ensure those two numbers, those two elements are 0. So step 6. For step 6, well, do we need to make those elements 0? Since we've achieved the pivot elements, let me see. To make those numbers 0, we can okay, yes, we can achieve those. We can achieve that. Can make those elements 0. What I'm going to do for row 1, I will replace. I will perform row 1 minus, or row 1 plus 1 5, row 1 plus 5 row 3. Yeah, I want to make that 0. No, plus 1 over 5 row 3, and then I will perform row 2. That is going to be row 2 minus 2 over 5 row 3. Let's apply this operation. So I'll perform the first operation, row 1 plus 1 over 5 row 3. So the first elements, because the last row 3 element 0 0, so this is going to be 1 0. Then when you multiply 1 over 5 by 1, that is 1 over 5. 1 over 5 minus 1 over 5, so row 1 is 1 over 5, or minus 1 over 5. Minus 1 over 5 plus 1 over 5, that's equal to 0. So this will give us 0. Let's multiply 1 over 5 by 1 over 8. That is going to give 1 over 40, right? So 1 over 40 plus 3 over 5. The LCM here is 40. So here we have 1 plus 24, right? That's 25 over 40. And we can break this down, 5 over 8. So this will give 5 over 8. Okay, I hope you're following with the calculations. That is 5 over 8. I'm trying to clear this space. All right. Next, we would perform the next, going to the next line. 1 over 5 times minus 1 over 4. That will give minus 1 over 20. Okay. Next, we add minus 1 over 5, minus 1 over 5, minus 1 over 20. The LCM here is 20. That is minus 4 minus 1. That will give minus 5 over 20, which is minus 1 over 4. So here is minus 1 over 4. And we multiply 1 over 5 by 5 over 8, and that will give 1 over 8. When you add 1 over 8 to 0, you get 1 over 8. Okay, so that settles for the row 1. Then row 2, let me clear this space. So we'll have enough space to continue with the calculation. For row 2, the operation is to multiply 2 over 5 by R3, subtract it from row 2. So row 2, this is 0. 0, so that remains 0. It's not going to change. The other is 0. That will become 1. It's not going to change. Then multiply 2 over 5. That is 2 over 5. So we have row 2, 2 over 5 minus 2 over 5. That is 0. Okay. Now multiply 2 over 5 by row 3, which is 1 over 8. So 2 over 5 times 1 over 8. This is 1, this is 4, that is 1 over 20. Minus 1 over 5 minus 1 over 20. So that is 20. This is minus 4 minus 1, which is minus 5 over 20. And that is minus 1 over 4. So this is minus 1 over 4. Then we also multiply 2 over 5 by minus 1 over 4, which is this guy right here. So 2 over 5 multiplied by minus 1 over 4, that is going to give us minus 1 over 10. All right. Now we will subtract minus 1 over 10 from minus 2 over 5. So that's going to be plus. The LCM here is 10. This is 4 plus 1, which is 5 over 10, and that is 1 over 2. So here we get 1 over 2. Okay. I hope this is making sense. And then we move on to the third column of row 2. We multiply 5 over 8 by 2 over 5, and that will give 1 over 4. Now we would subtract 0 from 1 over 4, that's minus 1 over 4. And the third row remains the same. 0, 0, 1, 1 over 8, minus 1 over 4, and 5 over 8. Okay, you can see we've reduced the matrix to an identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. With this that we've done, we can now say that therefore the inverse of A, this is what's called the Gauss-Jordan's rule or method, is equal to the matrix at the other side of the augmented matrix, 5 over 8 minus 1 over 4, 1 over 8, minus 1 over 4, 1 over 2, minus 1 over 4, 1 over 8, minus 1 over 4, 5 over 8, which can also be expressed as 1 over 8. I can factor out 1 over 8, and this will be left with 5. This is minus 2, this is 1, this is minus 2, this is 4, this is minus 2, here is 1, here is minus 2, and we have here as 5. Okay, so this is the inverse of matrix A. We just completed the solution to the first part of the question, part A. Here is the inverse of matrix A using the Gauss-Jordan elimination method. All right, and you can see that all the row operations were clearly stated. That's the instruction, that is the requirement. Now let's look at the second part of the question. Part B says verify your answer by computing A times A inverse and confirming it's equal to the identity matrix. Let's verify part B. Part B. Okay, let's verify. Verification. So to compute A inverse, what is the matrix A again? Matrix A is 2, 1, 0, 1, 3, 1, 0, 1, 2. That is 2, 1, 0, 1, 3, 1, 0, 1, 2. And the inverse we obtained is 1 over 8 and 5 minus 2, 1, minus 2, 4 minus 2, 1 minus 2, 5. That is 5 minus 2, 1, minus 2, 4 minus 2, 1 minus 2, 5. And this can also be written as 1 over 8 times 210 131 012 and 5 minus 21. Let me write that again clearly. 5 minus 21 minus 2 4 minus 2 1 minus 2 5. All right. Let's multiply. So we have the factor, the scale factor, or the scalar 1 over 8 outside. Don't forget how to multiply. I believe everybody still remembers how to multiply two matrices. This row multiply this column. All right. Let's go ahead with the multiplication. 2 times 5, right? That is 10. 10 plus 2 times minus 1, that is minus 2 plus 0. All right. Then the first row multiplies the second column also. Minus 2 times 2 times minus 2 is minus 4 plus 4 plus 0. Then we'll do the last column, that is 2 minus 2 plus 0. All right. Then we go to the next row, 1 3 1. Let's multiply 3 columns at the second matrix. 1 times 5 is 5. 3 times minus 2, that will give minus 6. 1 times 1 is 1. 1 times minus 2 is minus 2. 3 times 4 is 12. And 1 times minus 2 is minus 2. 1 times 1 is 1. 3 times minus 2 is minus 6. And 1 times 5 is 5. Then we move to the third row. 0 times 5 we give 5. We give 0. 1 times minus 2 is minus 2. And 2 times 1 is 2. 0 times minus 2 is 0. 1 times 4 is 4. And 2 times minus 2 is minus 4. 0 times 1 is 0. 1 times 2 is minus 2. And 2 times 5 is what? Plus 10. So this is the matrix. And when you simplify this further, we have 1 over 8 into, this is 8. Here is 0. Here is 0. This is 0. This is 8. And this is 0. So here is 0. Here is 0. And here is 8. Right? Open your brackets, multiply 1 over 8 by the element. You have 1 0 0 0 1 0 and 0 0 1. So as you can see, we have verified, it is verified that A times A inverse is equal to the identity element. This has been verified, which means that the inverse matrix we obtained, this inverse is indeed the inverse of matrix A. Then the third question, part C, which says states the determinant of A and explain its significance for the existence of the inverse of A. So part C, let me divide this again. Part C, let's look at part C together. We want to obtain the determinant of matrix A. So what is matrix A again? Matrix A is 2 1 0 1 3 1 0 1 2. All right, let's use the minor method to solve the determinant of A. We add the signs plus, minus, plus. Now I'll pick the first element plus 2 and obtain the minus. Let's do this with red ink. So I pick plus 2, then I'll obtain the minus. The minus will be all the element below it. 3 1 1, 2. Then I'll pick the element -1, and then all the elements below it. When you cancel the elements, we have 1, 1, 0, 2. Those are the minor of -1. Then I'll pick the elements as okay, that is +0. Whatever you have is going to be +0. So a determinant or determinant of a equals this. Determinant of a will therefore be 2 times 6 minus 1, because 2 times 3 is 6 minus 1. 2 minus 0 plus 0. So the determinant of a will therefore be equal to 2 times 5 minus 1 times 0 plus 0. And the determinant of a is therefore equal to 10 minus 2 plus 0, which is equal to 8. And in fact, we can see that indeed the determinant is equal to 8. So what's the significance? What's the significance? The significance is, let's see if we can write it here. I'll just state the significance. The significance is that since the determinant of A is not equal to 0, then it guarantees that the matrix A is indeed a non-singular matrix. Matrix A is non-singular. All right. Which means that matrix A is invertible, and in fact we've seen the inverse of A already, which also confirms what we're saying. So I can remember that a matrix is invertible if and only if its determinant is not 0. All right, so that's the significance, and that brings us to the end of the solution to question 1. Okay, as you can see, it's a very simple question, and I hope that you understand the solution from start to finish. At any point you missed out on any step, please feel free to ask during our lecture. I'll be happy to clarify further. All right, in the next video, I would go into the solution to the second question, and I hope that this is very helpful. Thank you for watching. Like, share, and drop a comment in the comment section in case you just want to make me see or understand what you feel about the video. Thank you and goodbye.